So, welcome back to Harburn 00, or indeed welcome to Harburn 00. This is number 3 in the build for the new engine shed, and it's a bit technical, but I'm going to try and keep it down a little touch here, folks. As far as the coding goes for the Nano, it's all been done by ChatGPT and Claudia on the computer there. My computing skills for programming this was soon been outstripped with the two of them. I take the batter, do them off each other, see who comes out the best code. So far I've got the code working, so I'll take you on the workbench there and we'll have a look at what we've done so far. Cheers. Now we bring it to this part here. This is the part that takes the 16 volts or the 16 volts DCC to something that Arduino can understand. So the DCC comes in the side here. You've got a 5 volts and a ground, and also the signal coming out this chip here, and this is an optocoupler, so it keeps the 5 volts and the DCC signal separate. Quite important when you work with your Arduino Nano is this chip here is a 6N137. The little PCB board was designed by one of the members at Merg, and he was kind enough to share them with me. So that's the board spot up here. There's just a little diode here and a couple of 3 resistors as well built into it. You can, I've seen various designs there with capacitors as well with it. And that's why I put the capacitor on the board just as a smoothing capacitor for the DCC signal. So it works, so that's the main thing. But, well, that's the technical bit as such. At the moment, as I say, things may change. I might change this for a Nano to a ESP32 or a BiCow 2, whatever. But at the moment, this works, so this is where we are at the moment. So this one here, this Nano here, this controls the doors. It's set up at the moment for 3 doors with the lights, LEDs as well, indicating when the servos are working. This drives this pulse wave module. We can drive up to 16 servos and also LEDs as pulse width modulation. So I'm utilising this for the servos and also the LEDs to indicate when the servos are running. That way you can turn the brightness down, the LEDs for example. This one here, this Nano here at the moment, this is doing the sounds. Same again. It is DCC accessory decoder programmed at the moment, same as this one here. And it's driving this Dy-SV5W MP3 player that plays the sounds. I can link this into this module and do away with this module. That may be an idea for the future. But at the moment, I'm just using it at the moment as the processor. Also, with this one here, the Nano is 5 volts, so therefore you've got to drive this with 3.3 volts, hence the voltage divider, a 2K resistor and also a 1K resistor tie in. Much like that, the middle part goes into the driver board, this part goes into the Nano, and this part here goes to ground. So, the last but not least, the technical part is this part here. This is a 6N137 module. I did buy these from a member of Merg, the PCB board. You can also make up yourself a bit of Vero board as well. PCB boards come like this here and just break them off. There's actually 6 on this board here at the moment. I did buy 9, but I don't need one board for each Nano. I can use the same board to do the signal for the DCC with the Nanos as a DCC decoder. Also a little speaker. I have designed the servo tray for the doors, so that can sit in there like so. We'll see how it goes there, folks. It's just a bit of work in progress. The same with the Nanos. We've got the shield at the moment for them, just to get a bit of protection from this, especially when you're using all these servos and different bits and pieces. So as I say, got the DCC signal coming in here. I've got the ECOS fire up as well, the command station there. I'll send across a little signal now for the door warning sign. And what you better do first, you daft bastard, is plug it in there. So I've got a 5V external power supply. I'll switch it on. Up fires here. One of the things that annoys me a little touch is this DY player does not have an LED to indicate it is on. I'm unsure when I first got it there if it was working or not, and I had to go and test it. So I'll play the first sound, which should be the door warning sign. Play it first. And I'm sure after a little while these doors going down, that sound will be annoying to say the least. I did put in 2 or 3 other workshop sounds as well, so this one, it's a little welder, and I've also got pin 9 on this to go to an LED to simulate the flicker as well. And the next sound we've got, it's a little air wrench going off. And the next one, angle grinder. The last one's a dog barking. Why not? I've said in this card here you can put thousands of sounds on what you want there. Unfortunately, this player here it can't play more than one sound at a time. So if you want the dog barking and the door noise going at the same time, you've had it. So down to the cost then, folks. These boards here, the Shield and the Nanos, they're a bit older. I think I paid back in the day 50 pence or £1 for each of these Nanos, and the boards were about £2.50. Nowadays the boards come at about £4, and the Nanos, depends what you do, you can go to Amazon, the Jungle, or I wouldn't go to AliExpress again, mind you, to test that company now. But certainly Amazon there, you can buy free boards for £9, £12 for free boards. And that is the new boards, I've got the USB-C rather than the old USB socket. The little sound chip came from China, Fleabay. Once again, it cost more for the postage than the package it did for the board. The board was about £4, including the postage and packaging. And the speaker, that came in there at £1 off eBay, and the same again there, it was £2.50 for the postage and packaging. And all PCA pulse width module itself there, that came in about £6. I did buy a packet 2 when I bought them, mind you, so not a lot of money for the electronic side of it. Of course we've got the sensors for the doors and servos as well for the doors, so it does start to build, but certainly for the DIYer and for my pocket money, I like the cost involved in this side. This is why I'm doing it. Certainly if I go to commercial there, I could not do the doors commercial because there's no a DCC decoder out there that can do a 360 continuous servo motor, or even that. You're going to get stepper motors, so you need to put in more software as well, more hardware for the stepper motors to do the job as well, and also the size wise. The servos there, they're quite thin. You've got the stepper motors there and you start them up in size, and certainly with the wee, certainly the cheap servo motors there, you're increasing the size considerably compared to a servo, and also the torque in this is actually terrible compared to a servo. A servo will lift up £1 in weight, the wee SG9's no problem, where this could lift itself out of a hole, to say the least. So that's where we are now, folks, with the module so far. So I hope you've enjoyed it. I don't go into too much technical detail with the software and the hardware side of it there. And of course, if you want to know a bit more, just drop my wee email. So thanks for watching, folks, and we'll catch you again some other time. Cheers.